Module 1, Fundamentals of Refinery Processes. Lecture 1, Introduction to Chemical Refinery Processes. Welcome to the course Chemical Refinery Processes. This course introduces the fundamental principles and techniques used in the processing of crude oil and other raw chemicals into usable products. Refining is the industrial process of separating, purifying, and transforming raw materials into fuels, petrochemicals, lubricants, and other chemical products. A chemical refinery is designed to convert complex mixtures into simpler, commercially valuable products. Understanding these processes requires knowledge of chemical engineering principles, thermodynamics, reaction kinetics, and process control. Lecture 2, Overview of the Petroleum Refinery. The petroleum refinery can be divided into three major sections. Upstream processes, initial separation of crude oil components through distillation. Conversion processes, chemical or thermal modification of hydrocarbons to produce higher value products. Treatment and finishing processes, removal of impurities and quality enhancement. Each section involves multiple unit operations and chemical reactions that contribute to the production of fuels and petrochemicals. Lecture 3, Crude oil composition and properties. Crude oil is a complex mixture of hydrocarbons including alkanes, paraffins, straight-chain or branched hydrocarbons, cycloalkanes, naphthalene, saturated ring compounds, aromatics, unsaturated ring compounds, impurities, sulfur, nitrogen, metals, and water. Physical properties such as density, viscosity, and boiling range determine how crude is processed in the refinery. Light crude is easier to process, while heavy crude requires more extensive conversion. Lecture 4, Primary separation processes. The first step in refining is separating crude oil into fractions. Atmospheric distillation heats crude oil to separate components based on boiling points. Vacuum distillation reduces pressure to distill heavier fractions without thermal decomposition. The result is a series of fractions including naphtha, kerosene, diesel, gas oils, and residual oils. Each fraction is processed further according to its intended use. Lecture 5, Secondary conversion processes. Conversion processes modify hydrocarbon molecules to produce high-value products. Common processes include cracking, breaking larger molecules into smaller ones. Thermal cracking. Catalytic cracking. Reforming, rearranging hydrocarbons to increase octane rating of gasoline. Hydrocracking, hydrogen-assisted cracking for producing jet fuel and diesel. Alkylation, combining small molecules to produce high-octane gasoline components. These processes enhance the yield and quality of fuels and petrochemical feedstocks. Lecture 6, Treatment and purification processes. Refinery streams often contain impurities that affect product quality. Treatment processes remove these contaminants. Desulfurization reduces sulfur content to meet environmental standards. Desalting removes heavy asphaltic components from residual oils. Hydrotreating, hydrogenation to remove sulfur, nitrogen, and metals. Solvent extraction separates undesirable aromatics or resins. Proper treatment ensures products meet performance, regulatory, and environmental specifications. Lecture 7, Fractionation and product blending. After conversion and treatment, products are fractionated and blended. Fractionation towers separate products into specific boiling ranges. Blending combines different streams to achieve required fuel properties like octane number or viscosity. Additives, antioxidants, detergents, and corrosion inhibitors enhance performance. Blending requires careful control to ensure consistent quality in gasoline, diesel, lubricants, and other refinery products. Lecture 8, Safety and environmental considerations. Chemical refining involves high temperatures, pressures, and flammable materials, making safety critical. Process safety, monitoring pressure, temperature, and flow to prevent accidents. Hazardous chemical handling, proper storage and handling of acids, hydrogen, and catalyst. Environmental compliance, controlling emissions, wastewater, and solid waste. Adhering to safety and environmental standards reduces operational risks and ensures regulatory compliance. Module 1 Summary. In this first module, we covered Introduction and structure of chemical refineries, crude oil composition and properties, primary separation, conversion, and treatment processes, fractionation, blending, and safety considerations. These foundational concepts prepare students to understand the advanced processes involved in modern chemical refineries.